A limitless scene is fanning out as we talk, charming stargazers all around the planet. Betelgeuse, the spellbinding red supergiant, is undergoing a striking change. This imminent monster, known for its heavenly red tone, has been a staple of the colder season of our sky for quite a while, drawing the awe and wonder of stargazers from ancient human civilizations to modern-day astronomers. What makes this change so phenomenal is not simply the changes happening inside the actual star, but the sheer scale and speed with which they are happening. This huge star, usually more prominent than our Sun, is showing us precisely how dynamic and unpredictable the universe can be. Betelgeuse's brilliant glow, which describes its magnificent presence, has surged past its usual brightness by a staggering half. Imagine a light suddenly multiplying in splendor, projecting its shine further with greater power. That is what's happening with Betelgeuse on an immense scale. At the start of this year, Betelgeuse proudly held the title of the 10th most brilliant star gracing our night sky. Its steady, consistent light was a constant beacon of stability. However, this unexpected grand surge has pushed it to a new position, currently shining brilliantly as the 7th most brilliant star in our night sky. This leap in brilliance has sparked excitement and interest within the cosmic community, leading to new observations and studies to understand the forces driving this dramatic change. Betelgeuse, a massive star in its later stages of life, is enormous. Its supernova aspects are so great that if it were positioned at the center of our solar system, it would extend as far as Jupiter's orbit. Eventually, this star will undergo a collapse resulting in a powerful supernova explosion that could lead to the formation of either a neutron star or a black hole. The anticipation surrounding Betelgeuse's supernova comes from the fact that it will be a remarkable event located about 650 light-years away. Humanity finds itself in a prime position to witness this spectacular display firsthand. When the supernova occurs, it will produce a stunning display of light. Initially, there will be an unexpected burst of neutrinos that will sweep across the Earth, detectable by observatories worldwide. Following this, as high-energy photons escape from the expanding cloud of stellar debris, Betelgeuse will rapidly increase in brightness over the course of 7 days, reaching up to 100 times its normal brilliance. Depending on the explosion's power, this celestial event could rival the brightness of a full moon and might even be visible during daylight, casting distinct shadows at night. This brilliant event will continue for a considerable period, offering a valuable opportunity for detailed observations and potentially significant discoveries. While Betelgeuse's supernova could provoke speculation and concern due to historical associations of such events with ominous signs, we can be assured that we are safely positioned at a significant distance from any harmful effects. To fully understand the mystery surrounding Betelgeuse, it is crucial to revisit the end of 2019 when curious anomalies began to appear. During this period, the red supergiant star began experiencing significant dimming, a change noticeable even to the naked eye. Observations using the extremely large telescope in the optical range revealed that Betelgeuse appeared generally uniform, but its photospheric layers showed signs of significant disturbance. Surface mass ejection, the photosphere representing the outer layer of the star where light is produced, showed an expansion, giving the impression that the star was enlarging when viewed from Earth. This expansion continued at a steady rate of around 8 kilometers per second for most of the year until mid-November 2019. By then, the outward movement began to slow, and by mid-November, the flow of material from Betelgeuse ceased, prompting astronomers to capture new optical images of the star. Their observations revealed 2 significant anomalies. A darkened region appeared on the star's southern hemisphere, contrasting sharply with the previous image taken at the start of the year, and the star's surface temperature decreased by around 80 Kelvin between January 27 and February 13, 2020. Betelgeuse's brightness reached a super low point about a year after the end of the surge, but the star gradually regained its brilliance over the subsequent months, eventually returning to its normal size. This led to the question of what had truly happened with Betelgeuse. All available evidence strongly suggested that Betelgeuse had undergone a massive and intriguing event known as a surface mass ejection, SME. This phenomenon bears similarities to coronal mass ejections, CMEs, observed on the Sun. To better understand SMEs, imagine a volcanic eruption on a stellar scale, where material from the star's interior erupts outward, causing shock waves within its atmosphere. Over time, this material forms particles and dust, somewhat obscuring our view of the star and making it appear dimmer. In the case of Betelgeuse, the SME resulted in the ejection of a mass 400 billion times greater than what is typically observed during similar events on other stars or CMEs. This amounted to roughly the mass of the Moon ejected at a single rate. Scientists noted that such a massive ejection from a star's surface had never been seen before. The event allowed for direct observation and assessment of surface details using the Hubble telescope, providing a real-time view into the aging and evolution of a dying star. This episode significantly impacted Betelgeuse, causing it to lose a substantial amount of mass in a single event, showcasing how a dying star can experience significant mass loss beyond its normal annual decrease due to solar wind. Betelgeuse had likely expelled its outer layers violently and was now in the process of gradually recovering from the aftermath of this event. However, following this dimming episode, the star's behavior changed. Previously, Betelgeuse would fluctuate or vary its brightness at regular intervals, but now it is pulsating at regular intervals. Betelgeuse is classified as a semi-regular variable star, meaning it undergoes different patterns of changing brightness due to changes in its size and temperature. This red supergiant is known to exhibit two distinct pulsation periods. The primary period lasts 400 days and is believed to be caused by pulsations in the first mode, while the secondary period is a longer pattern of around 5.6 years, with its origin remaining unclear. In their research paper, scientists used computational models to gain a deeper understanding of the events that occurred. They proposed that a particularly hot gas bubble, resembling a large and intense balloon, rose from inside the star. These bursts of hot gas bubbles sometimes arise due to the star's turbulent and convective envelope, which can be compared to a pot of boiling soup where material is constantly moving and mixing. As this hot bubble rose and broke through the star's surface, it triggered the release of stellar material. Interestingly, it also disrupted the star's normal pulsation pattern. The star's surface continued to expand while its deeper layers contracted, causing the star to shift from its usual 400-day pulsation cycle to a new 200-day pulsation cycle. Astronomers estimate that the star's normal pulsation patterns will gradually stabilize, returning Betelgeuse to its typical multi-year cycle over the next 5 to 10 years. Regarding the likelihood of a Betelgeuse supernova, researchers estimate that it could occur any time within the next 10,000 to 100,000 years. Based on factors such as the star's color, brightness, size, and estimated age, scientists suggest that Betelgeuse is currently in the early stages of helium to carbon fusion. This process will continue through oxygen, silicon, and eventually iron before the star's core collapses under its own gravitational pull, leading to a tremendous explosion. Since Betelgeuse is located 650 light-years away, any supernova event happening now would only become visible to us after 650 years due to the constraints imposed by the speed of light. Consequently, it is highly unlikely that we will witness the star's dramatic end during our lifetime. The unique aspect of Betelgeuse is that we can actually observe its surface, which is not the case for most other stars. This provides us with a rare opportunity to learn about how massive stars like Betelgeuse behave as they age, including these kinds of dramatic mass ejection events. Recently, astronomers made a surprising discovery. For the first time, they observed a star consuming its own planet located 12,000 light-years away in the constellation Aa. Betelgeuse, with its captivating name and prominent position in the night sky, has fascinated the human imagination for centuries. Its significance extends beyond scientific knowledge, as it has influenced popular culture and mythology around the world. Betelgeuse has a rich and varied origin rooted in the Arabic language, originally interpreted as the armpit of the giant. Some researchers argue that it could refer to a hand or shoulder instead. This physical association is reflected in various interpretations of Betelgeuse, often linked to human or animal figures across different cultures and legends. Betelgeuse carries different meanings and symbolism. In ancient Japan, it represented a severed limb, while in Brazil, it was viewed as a turtle's leg or a caiman's rear leg. The Sanskrit term for Betelgeuse means the moist one, related to Hindu astrology, Ardra lunar house, and associated with the storm god Rudra. Over time, Betelgeuse has played a significant role in cultural practices and traditions. For example, in Macedonian traditions, it symbolized domesticated animals and agricultural life in villages. In various regions, such as North Baffin Island and the Melville Peninsula, its rising marked the beginning of spring and longer days. Betelgeuse's cultural prominence stems from its association with the constellation or asterism, considered one of the most conspicuous and culturally significant patterns in the night sky. The fascination with Betelgeuse extends beyond its immediate scientific interest, touching on numerous aspects of human curiosity and cultural significance. This red supergiant's dramatic changes offer a window into the life cycle of massive stars, which are pivotal in the cosmic ecosystem. As these stars evolve, they play a crucial role in the creation and distribution of heavy elements necessary for the formation of planets and life. The explosive end of such stars not only contributes to the galactic chemical enrichment, but also impacts the formation of new stars and planetary systems. In stellar astrophysics, Betelgeuse represents a key example of a star nearing the end of its life. Supergiants like Betelgeuse are critical to understanding the life cycles of the largest stars, which differ significantly from those of smaller, more familiar stars like our Sun. The study of these massive stars helps astronomers to piece together the complex puzzle of stellar evolution and the life cycles of different types of stars. Observing Betelgeuse as it transitions through these late stages provides valuable insights into the mechanisms that govern star evolution, including the processes leading up to supernovae. The changes observed in Betelgeuse also serve as a reminder of the dynamic nature of the universe. The star's sudden surge in brightness and subsequent dimming highlight the inherent unpredictability of celestial bodies. Such phenomena challenge our understanding of stellar behavior and encourage further research into the underlying causes of these dramatic shifts. Scientists employ advanced modeling and observational techniques to predict and analyze these changes, striving to refine our models of stellar physics. Betelgeuse's story is not merely an astronomical curiosity, but a testament to the broader quest for knowledge that drives humanity to explore the cosmos. The star's recent behavior has prompted a wave of scientific inquiry, with researchers examining everything from the detailed structure of its outer layers to the potential implications of its eventual supernova. These investigations are part of a larger effort to comprehend the fundamental processes governing the universe, contributing to our grasp of how stars influence the formation of galaxies and the evolution of cosmic structures. The cultural impact of Betelgeuse also extends to popular media and literature. The star's name and distinctive characteristics have inspired numerous references in films, books, and other media. For example, the 1988 film Betelgeuse, directed by Tim Burton, adopted the name of the star for its titular character, weaving it into a fantastical narrative that blends horror and comedy. While the film is a playful take on the name, it underscores how celestial objects like Betelgeuse capture the imagination and inspire creative works that reach beyond the scientific community. In addition to its cultural significance, Betelgeuse has played a role in various historical astronomical observations. Ancient astronomers and stargazers often recorded the positions and behaviors of prominent stars like Betelgeuse, contributing to early astronomical charts and star catalogs. These records provide a historical context for understanding how our knowledge of the cosmos has evolved over millennia. By studying historical observations, modern astronomers can track changes in stellar brightness and position over long periods, offering insights into how stars like Betelgeuse have behaved throughout history. The study of Betelgeuse also intersects with the field of astrobiology. As scientists investigate the life cycles of massive stars, they consider the implications for potential extraterrestrial life. The heavy elements forged in supernovae are essential for the formation of planets and the development of life. Understanding how these processes work can provide clues about the conditions necessary for life to arise elsewhere in the universe. Betelgeuse's eventual supernova will contribute to the cosmic distribution of elements, potentially influencing the development of new star systems and planetary bodies. In recent years, advancements in observational technology have revolutionized our ability to study distant stars like Betelgeuse. The development of more sensitive telescopes and imaging techniques has allowed scientists to observe stars with unprecedented detail. Instruments such as the Hubble Space Telescope and the upcoming James Webb Space Telescope provide critical data that enhance our understanding of stellar phenomena. These tools enable astronomers to monitor changes in stars over time, study their internal structures, and analyze their compositions with greater precision. The impact of these technological advancements extends beyond individual stars. By observing a range of celestial objects, including supergiants like Betelgeuse, astronomers can develop more comprehensive models of stellar evolution. These models help to explain not only the life cycles of stars, but also the broader processes that govern the formation and evolution of galaxies. Understanding how massive stars contribute to these processes is crucial for piecing together the history of the universe. Moreover, Betelgeuse's behavior provides a unique opportunity to study the effects of stellar evolution on nearby astronomical phenomena. For instance, the massive ejection of material from Betelgeuse may interact with interstellar medium, influencing the formation of new stars and planetary systems in its vicinity. Such interactions can have cascading effects on the local galactic environment, shaping the future evolution of nearby cosmic structures. In summary, Betelgeuse represents a fascinating intersection of scientific inquiry, cultural significance, and technological advancement. Its dramatic changes offer a glimpse into the dynamic nature of the universe and the intricate processes that govern stellar life cycles. As researchers continue to study this red supergiant, they contribute to a broader understanding of how stars influence the cosmos and the potential for life beyond Earth. The continued observation and analysis of Betelgeuse and similar stars will remain a vital part of our quest to understand the universe and our place within it.